Our universe is enormous in both size and complexity. Even though scientists have discovered great things, we still know very little about the universe. Space exploration and the exponential expansion of technology in this century have resulted in numerous stunning and at times mind-boggling revelations about the vastness of the universe. The cosmos is commonly shown as a gigantic sphere filled with galaxies, stars, and other large physical phenomena. However, how can scientists back up their claims with evidence? Having discovered something so vast and scary that it shrinks our own galaxy to the size of a pinprick and our solar system to the size of a grain of sand. What precisely is this revolutionary discovery? What impact might it have on the planets we leave behind? Join us as we are going to explore the massive structure outside the Milky Way galaxy. First, let's look at the Milky Way galaxy. Scientists have spotted something so enormous and terrifying that it makes our home galaxy look like a dwarf, and our solar system seem like a grain of sand. Our Sun and its surrounding planets orbit within the Milky Way galaxy. The name of this galaxy reflects how it appears from our home planet. The Milky Way appears to us as a diffuse band of light in the sky, and its constituent stars appear too dim for us to make out individually. The Latin term lactea, meaning milky circle, is the origin of our English name for the Milky Way. The Milky Way appears as a narrow band when viewed from Earth because the galaxy's disk structure is obscured by the Earth's atmosphere. In 1610, Galileo Galilei was the first to successfully separate the individual stars within this band of light using his telescope. Remarkably, practically all astronomers believe that the Milky Way contained the entirety of the universe's stars. The Milky Way was once thought to be the only galaxy in the universe. Still, discoveries made by Edwin Hubble and a heated discussion between Harlow Shapley and Heber Curtis in the 1920s shifted that view. However, the thickness of the galaxy's spiral arms is just about 10 light years. The most recent scientific models have also hinted at a dark matter region with a diameter of up to 2 million light years, which also contains some visible stars. Our galaxy is a member of the Virgo supercluster's local group of galaxies. The stars and galaxies orbiting the Milky Way. This cluster is a part of the larger Lani, aka supercluster. Several galaxies orbit the Milky Way. Many scientists estimate that the Milky Way galaxy has between 100 and 400 billion stars and at least many planets. Our solar system is situated on the inner edge of a spiral-shaped concentration of gas and dust called the Orion Arm, some 270 light-years from the galactic center. A supermassive black hole containing about 4 million suns has been identified as the powerful radio emitter known as Sagittarius at the center of our Milky Way. These galaxies and stars, which are spread across the galaxy, orbit the core of the Milky Way at a rate of around 220 kilometers per second. Several researchers have concluded that this permanently high rotation rate is at odds with Keplerian dynamics. Since most of the mass in the Milky Way doesn't generate or absorb electromagnetic radiation, astronomers have determined that it must be invisible to telescopes. This total mass is now known to be composed entirely of dark matter. At a speed of 600 kilometers per second, the Milky Way is truly spectacular. More specifics on the Milky Way. According to the extragalactic reference frames, researchers have discovered that the oldest stars in the Milky Way are nearly as old as the universe and were likely born shortly after the epoch of the famed Big Bang. According to experts, the Milky Way is considered one of the two largest galaxies in the local group. The second is called Andromeda. The Milky Way's mass is anywhere between 890 billion and 154 trillion times that of our Sun. Astronomers using cutting-edge instruments have uncovered a lot of activity within this galaxy. Along with the trillions of stars and planets, there are tens of billions of white dwarfs, billions of neutron stars, and nearly 100 million stellar black holes. The interstellar medium is a gas disk that fills the star's space. But there's also a lot going on outside our Milky Way. Astronomers have lately picked up on something quite disturbing, nearly 730 million light years from Earth. Big bangs and crashes seem to hold a special fascination for astronomers. They're always trying to outdo one another with the largest and most brilliant one they can locate. The mesmerizing discovery. What could be more exciting than witnessing the explosion caused by the impact of two of the largest objects in the universe? A new study presenting one of the most detailed images of a massive shockwave was published in the Journal of Astronomy and Astrophysics in February 2022. A mesmerizing cluster of galaxies known as the Abell 367. Both galaxy clusters collided to form this structure. The 550 galaxies that make up reality Abell 367 are steadily blending to form a single cosmic soup. Because of the collision of these two galaxy clusters, scientists have detected a massive shockwave. At the moment, most telescopes cannot see it. On the other hand, this cosmic impact has caused tremendous disruption to sweep through the area. Observed solely at radio frequencies, experts have described it as a gigantic shockwave exploding out from both ends of the merging cluster. Researchers using the Meerkat radio telescope array in South Africa show the radio remnants of the two parts of the shockwave. According to the results of this research, the complexity of these structures is much more than previously thought. Francesco de Gasparin, a visiting scientist at the Hamburg Observatory in Germany and the study's principal author, claims that the shockwaves act as huge particle accelerators that speed electrons up to almost the speed of light. The shockwave and massive energy released from the collision. Throughout the waves runs a complex web of glowing filaments that can be used to infer the location of massive magnetic field lines and regions where electron acceleration occurs. Even if the shockwave was only recently discovered, it has been there for a long time. It was formed approximately 1 billion years ago when the two clusters of galaxies that make up Abell 367 first clashed. Clusters of galaxies are some of the most massive gravitationally bound formations known. When two clusters collide, they produce an equivalently massive amount of energy. Scientists believe this event represents the single biggest energy discharge in the universe since the Big Bang. When the clusters met 1 billion years ago, a surge of electrons was released, and that incredible speed of 1500 kilometers per second is still maintained by those particles today. These particles generate radio waves as they travel through magnetic fields. What Dr. Gasparin's team saw through the Meerkat were radio waves. However, the radio waves were not sufficient to fully define the shockwave. The XMM Newton X-ray Observatory has also studied the table. The massive cloud of cosmic gas. You may see the white color in the middle of Abell 367 if you look attentively at this picture. There are about 550 separate galaxies clustered here, but the red colors on either side indicate shockwaves generated when the supercluster was formed. This finding is revolutionary for understanding how galaxy clusters form and collide. A group of astronomers from the University of Alabama in Huntsville, led by Chengi, used the XMN Newton X-ray telescope at the European Southern Observatory and the multi-unit spectroscopic explorer at the Very Large Telescope and the Subaru telescope to perform their research. The researchers found a massive cloud of hot, dimly lit plasma in space, considerably larger than our Milky Way galaxy. Unique among cosmic gas clouds, this one may have been ripped off a galaxy. The unexpected finding was that the cloud had remained clumped together for hundreds of millions of years, rather than dispersing. The X-ray emission analysis led the research team to believe that the cloud was significantly bigger than they had first thought. They estimate that the mass of this cloud is roughly 1,100,000. Ming Sun, a physicist at the University of Alabama, said the finding shows how astronomy constantly produces unexpected results. Finally, more entail the massive cosmic cloud. It was determined in the investigation that the orphan cloud had a temperature of between 100,000 and 1 billion Kelvin. This temperature is in keeping with gas found within galaxies, lending credence to the idea that the cloud was ripped from a galaxy as it traveled through space. Dr. Sun also shared that the cloud was discovered in the galaxy cluster known as Abell 367, or the Leo cluster. It's roughly 300 trillion miles from Earth. After being removed from its galaxy so long ago, the scientists were eager to learn why the gas had not dissipated. They determined through calculations that the gas cloud may be kept together for a considerable amount of time despite the instabilities using a magnetic field. Given the size of this cloud, it stands to reason that the galaxy it tore away from was massive as well. As a result, the research team is hopeful that this cloud will help them locate the galaxy from whence it originated. Researchers can use this information to better spot future examples of this type of cloud. Well, that marks the end of today's video. I hope you enjoyed yourself. Remember to like, subscribe, and leave a comment down below. Thanks for tuning in.